introduce Christine, who's going to be talking about reverse engineering on iOS. This is going to be an awesome talk because for a lot of us, myself included, reverse engineering on iOS seems a little daunting, but I think Christine's going to dispel that and give us the tools to help us become proficient iOS reversers. So hand it off to Christine. Round of applause.
Thank you. Thank you for having me. So my name is Christine Fossaceca, and my talk is Reverse Engineering iOS with Frida. So a little bit about me. I'm a senior reverse engineer at the MITRE Corporation. I specialize in mobile reverse engineering, specifically iOS. I'm considered an iOS reverse engineering subject matter expert, and I do really enjoy reverse engineering iOS. In addition to that, I'm also a researcher, part of the Furious Mac research team, which is a collaboration between MITRE and the United States Naval Academy. Photo op. And so our research team focuses on mentoring midshipmen and teaching them about different security and privacy topics, and also publishing. So I've had the opportunity to publish a paper with some of the professors at the Naval Academy. We recently just got a paper accepted into the workshop on privacy in the Electronic Society, and our paper is on circumventing Apple's AirTag anti-tracking framework. So you heard Ava talk about it in her keynote, and you can learn even more about it in November 2021. I'm also a dog mom, and I thought I needed to introduce Honey because she'll be making an appearance in some of my later slides. Unfortunately, she couldn't be here in Hawaii in person. I'm also an advocate for women in cyber. I'm part of the Black Hoodie Discord group, which was started by Marian Marshalik, Pink Flawed on Twitter. I've also presented a lot of intro to reverse engineering topics at WESIS and at the Diana Initiative. And I'm also a co-host at Her Hacks Podcast, which is a podcast by women for everyone, where we talk about different experiences that we have as women in cyber, as well as talk about technical topics like how to stay private online. All right, so what you came here for. I'm going to teach you how to reverse engineer iOS using Frida. But first, I want to tell you a little bit about Frida, give you a little bit of history, then I'll tell you how you can set it up. And then I want to walk you through my methodologies. This is kind of like what I do. I have 3 main uses of Frida, 3 main methodologies on how I reverse engineer depending on what I'm doing. So I want to walk you through those so that you can do them yourself. And then I'm going to tell you some hot tool tips, which are just things I've picked up from some of my peers in the industry who've either also given a Frida presentation or I've asked them a question and they told me, like, this is how you do that. So I would like to share that with you. And then if we have time, I'll have some questions at the end. All right. So Frida, this is a very brief history. So it was created by Olandre Ravnas, who is a researcher at NowSecure. And you probably noticed that my last name is kind of hard to pronounce, and his name I was very confused. So he very kindly sent me a voice memo on how to pronounce it. And he also is really nice because he always answers all of my Frida questions whenever I send him Twitter DMs. But he presented on Frida in 2015, and he said, think of it as a library for building debuggers, which is interesting because you might want to debug something. So you're like, okay, this is a tool, so I don't have to start from scratch, and I have some foundation to build blocks on top of, which is interesting. And then if you go on their website, you'll see that Frida is a dynamic instrumentation toolkit, and you're like, okay, so what does that mean? So let's dive into that a little bit. Some of you might know what that means. Some of you may not. So when I first hear dynamic, I think of it in the context of static analysis and dynamic analysis, like in reverse engineering. So static is code that is not running, and dynamic is code that is running. So as a dynamic analysis toolkit, Frida is running, so you're using it on a running process. Instrumentation is also a weird word. When I first heard it, I was like, I don't know, what does that mean? And that just describes how you're handling the binary itself. So normally when you're writing C or if you're writing Python, you can write your own debug statements. You can write information before a function is called, after a function is called, during being called. But you can't do that on a black box binary because you don't have the source code. So Frida can be used to inject code into a process using JavaScript. So dynamic instrumentation is literally taking a running process and shoving code either before the function, into the function, after the function. You can modify the parameters, you can modify the return value, you can modify any of the computational methods that are happening during execution. So it's pretty powerful, and it's useful, especially if you're doing native process debugging, which is an example where you would never have source code unless you literally work at Apple, like some people in the audience. So in general, Frida also is really great because it's actually available on almost every platform. You can use it on macOS, on PC, on Linux. Your host machine can be the target, or you can have a remote device like Android or iOS. And you can also use it to debug Node.js, which makes sense because you're using JavaScript injection. So of course you can use JavaScript to debug itself. And it can be used for application reversing or native process reversing. So my presentation is going to be specifically on native process reversing, but there's a really great tutorial for reverse engineering iOS apps, which was given by Or Begum of Celebrate in his DFRWS 2020 workshop, and he goes into how to reverse engineer Instagram. So that's really awesome if you want to look at application-specific debugging. All right, so we're just gonna jump into the demo. So if you're rewatching this talk, if you want to follow along or if you want to do it later, you can use exactly what I'm doing or you can do your own thing. You just need an iPhone and a computer. I'm specifically using an iPhone 7. It's on iOS 14.7.1, and you'll see later why I haven't updated. I'm using the checkra1n jailbreak, and I'm using Frida 15. So prepping your computer, it's really easy. All you have to do is pip install Frida tools, and then you're done. Frida 15 was recently released, and it was built with Python 3.9, and I recommend having the latest version of Python. Your mileage will vary if you don't, so 3.9, Frida 15. Also, you probably want to have the same version of Frida on your phone as on your computer, because if you don't have the same version, there could be like issues with how it communicates. So make sure that the one that you put on your device is the same, and I can show you how to check that as well. So Frida on your host machine is relatively easy. Frida on your device, not as easy. So if you have an iPhone that's an iPhone 10 or earlier, you can just use checkra1n. I think before checkra1n came out, jailbreaking could have been like an entire conference talk, but now like all of that stuff is pretty deprecated. The old tools that people used to work like City Impactor are like, they don't even work anymore because all the stuff was changed. So checkra1n has really changed the game. And if you haven't heard of it, it's a jailbreak that's built on the checkmate exploit, and so it only works on the A11 chipset and earlier because it's an exploit in Apple's application processor. So it will never work on anything like A12 Bionic or later, so that's why like XS, XR, you can't use checkra1n. But if you do have like an iPhone 11 and you're like, well, how am I supposed to do this demo? You can actually use a different jailbreak. So AltStore is a great tool that you can use to sideload, and you have to pair it with a specific jailbreak. So there's tons out there. I think Uncover is one of the most reliable jailbreaks. That's the one I use for later devices. One main difference between checkra1n and Uncover is checkra1n will work even on newer versions of iOS. They usually release beta releases, and they say that it's not supported, but then they actually allow you to modify some parameters and say, yeah, I'm like willing to take the risk to brick my phone and just run it. And like 9 times out of 10, checkra1n will work even on 14.7.1, even on 14.8, which I just tried. Unfortunately with Uncover, you can't do that. So they have like a check where they check your OS and they're like, sorry, we haven't released that. No, you may not run at your own risk. So yeah, that's one thing. If you have like a phone on a newer version, you literally just you have to make your own jailbreak or wait for the Uncover people to release something new. Also, I don't think anyone has any iPhone 5s anymore, but if you do, I'm sorry. This is for 64-bit devices only. All right, so last step to prepare your iOS device. Normally, jailbreaks will give you Cydia, which is basically a package manager for anything that's jailbroken. But if for some reason the jailbreak that you're using didn't include Cydia, you can just download it directly from Sorik's website. They have Debian files, and you just double-click it and install, and you're good. Frida's not a default source in Cydia, so you can just add it as a source and then download and install Frida, and you're ready to go. The one thing is you want to make sure you pick the top Frida because they recently updated. So previously there was all of these different versions of Frida because there was Frida for 32-bit devices. There was Frida for, and that's a 32-bit SEP, not 32-bit AP. And then Frida for A12 Plus, which is 64-bit SEP and later. So Frida 15 came out and kind of combined everything together so that you just need one version of Frida. So that's why just pick that one. And so I can actually show you on my phone. So this is jailbroken. If you go to Cydia, you look at your installed packages. I'm on 15.1.3, which is fine. So then I know that I picked the right one. So that's a way to check if you clicked and you're not sure. All right, so we're done. We're ready. All right, so now I'm gonna actually just show you. So I always try to sanity check first because sometimes you might accidentally have the wrong version of Frida or something's not working that's supposed to. Maybe there's your version of iOS needs a certain cherry-picked pull request from GitHub or something, because you can also build Frida yourself. So just to make sure everything's working, double check your Frida version, just like Python. And then you can call Frida PS. PS stands for process list. You probably all know that. And then -U, which is USB. So one common pitfall that I have when I'm usually doing stuff with Frida is sometimes I forget to do the -U, and then I'm why can I not find this process? What is going on? And oh, I forgot the U. So everything seems like it's working. So then we'll just jump into the methodology. So the first one is called Connect and Explore. This methodology is more for when you're just trying to kind of see what's going on in the phone. Maybe you need to get the load addresses of some certain libraries. You want to see kind of what's happening, and you're just not really sure what you want to do. Or you want to write a lot of JavaScript, which I don't like doing, but that's what I use this for. So, and because I have done a lot of AirTag reversing, I have done a lot of Frida usage with Bluetooth D, so that's what I'm going to demonstrate today. So it's really easy. You just say Frida-U Bluetooth D. And then, can everybody see this? Is this big enough? Because if not, I can make it bigger. Good? Okay. And that's it. So you can either use the process name or the PID. So something that can be a little discouraging when you first use Frida, even though there's a lot of great features and it is on version 15, it still is freeware. So things like this happen, and you're did I just download malware? What is this? But it's not their fault. It's a great tool. Just, they got a lot of things that are really great that they're adding. So instead, you tab complete. And this is how you use Frida. So if you don't know what you're doing and you're oh, I don't remember what Christine said, or I want to explore something different, just tab complete and you can explore all of these different modules, which is really awesome. So as an example, something that's kind of cool is they have this math one, kind of like NumPy, I guess. And you have some constants that you might want to use. They have functions like absolute value. So I don't know, MATLAB maybe, if you're doing something like that. So that's interesting. It's just kind of fun things to play with. So what we want to look at is the process itself. So we can type process, and it'll tell us the architecture, code signing policy. We'll get the PID again. So now what we want to look at is the libraries that are accessed by this process, because we want to figure out what are some libraries that are touched by Bluetooth D. So we can say mods equals process dot enumerate modules, and save it into a variable, and then it prints out. So you might be confused because I keep saying modules, and that's not really a word that we hear in iOS. And then when I say modules, but you're seeing like DYLD and like some dilibs, and then if I scroll up a little more, you see like some frameworks, and you're like, what is she talking about? What is a module? What is happening? And so go back to the slides. This is an old slide from Jonathan Levin's class. It says OS X architecture, but it's like kind of the same thing, like macOS and iOS. So I'm saying modules in Frida, and in Apple we just say like frameworks or private frameworks or public frameworks. A module is a library, is a framework. It's all the same thing. So I might say library, might say module, might say framework. And in this talk, I'm just talking about like dynamically linked libraries. And if you look at this architecture, CLI like daemons, this is my Bluetooth D for daemon, and it's calling these different public and private frameworks. So just so there's no confusion, somebody else is in their talk talking about, you want to have the same language. So I thought that might be helpful. So this is interesting, but I just saw like every single module that's touched by Bluetooth D, and I don't want to reverse engineer all of Bluetooth D. I want to look at like a very small part of Bluetooth D. So something I can do is actually run a filter. So you can say list mods as a new variable, and then I can have this filter function, and I can literally just sort through this list. And then I find 3 interesting libraries. So now I can get closer to finding that needle in the haystack. And what's really awesome is you get the base address. So this is the actual base address loaded in memory of that library. So that's awesome for finding like function offsets and things that you need if you're trying to figure out where a function is being called, or if you want to hook into a specific function. You also have the entire path, so you know where to find it on the phone if you want to pull that binary off the device. The other thing that you might want to do is maybe there's a reason that you're trying to like modify memory, and you want to know like if there's readable, writable, executable memory. So you can say process enumerate ranges, and then like if you want readable, writable memory, and then it will actually list out in a dictionary for you all of the ranges, where they start, how big they are. So that I found helpful in the past. The last thing I want to show you in this Frida CLI is how to connect a script, because it can be really annoying. Like once you kind of know what you're doing, you're like, oh, I don't want to have to keep typing in this window all the time. I want to be able to move a little bit faster. So here's a very simple JavaScript script. It's also probably very small. Can you guys see that? There, maybe that's a little better. So you can connect again with the command line using the -L flag. So Frida -U, Bluetooth D -L, enumerate modules, module names. All right. And it's just printing out those same module names that we saw before. So something else you can do if you don't want to disconnect and reconnect, you can just literally paste into that window. And I found that helpful because sometimes I just want to run a script. So, all right, now you know where to find a library that might be interesting to you. You know how to find the load address. But you're like, Christine, that's not really interesting. Like, I want to know specific functions. I want to know how I can hook a specific function, get some data that I might want. And you can do that. But you need my second methodology, which I call catch and release. So this is using Frida trace. So one other pitfall with Frida trace is you need to be aware, in iOS specifically, of Objective-C versus non-Objective-C functions. So you might think that you have the right syntax, and then if you don't and you have the wrong flag, you will not hook anything. So like as an example, if I said Frida trace -I, and then I put this Objective-C syntax in, nothing would hook. And I'd be like, oh, there's no functions called location that Bluetooth D uses? Like, that doesn't make any sense. So really just be careful with the syntax. So -M is for location, is for Objective-C, and -I is for non-Objective-C functions. So I thought it would be fun if I did a demonstration on reverse engineering the iOS zero-click exploit, showing how I can use Frida trace to actuate. I know a lot of people already talked about this. I'm like the fourth person to talk about it. I'm just going to talk about it again in case some people didn't see the other talks. So this was first reported as Megalodon by Amnesty International, and then it was later reported by Citizen Lab as forced entry. There's also another report, Mickey Jin reverse engineered this and published it with Trend Micro. I recommend reading that. I took a screenshot from that for this presentation. So basically, the exploit was a series of GIFs that were maliciously encoded as PDFs and sent to a target device via iMessage. So in this demonstration, I'm going to show you how you can trigger some of those same functions using iMessage. I thought it was weird, but also interesting how sending a GIF could trigger something in PDF. So I started looking into Mickey's report to figure out kind of what was going on. So in this screenshot, he actually reverse engineered the actual exploit function, and then he looked at Apple's patch to see what had changed. So the exploit itself was in the JBig toStream read text region function, which is here at the top. But then we can see there's like a call chain of other functions. So core graphics was the main framework or library that was affected here, and you see something called CG-PDF source. And so I thought this was particularly interesting, and I wanted to focus on this. So let's go back here. So what I decided to do was use Frida trace, and this time, because we're looking at iMessage, I'm connecting to the messages process, and then it's a non-Objective-C function. You can see in here it's just a normal function name that's not Objective-C syntax. So I use quotes and then asterisk CG PDF source, and I'm going to try to connect to my target device. So let me also pull up my device so that you can see what's happening. So something that's a little bit different between Messages and Bluetooth D is Messages won't let you connect right away because of the way that the process is like idle. There's actually a helper process that controls when Messages is triggered. So the helper process is always running, but Messages is in this idle state. So you can watch, if I don't attach in time, it will fail. So failed to attach. So what you have to do if you want to connect to Messages is you can just like send a text message or something, or an iMessage message just to actuate. So now you can see that it's connecting, I got this text message, and it's instrumenting. And suddenly I hooked all of these functions. So now I'm gonna send a GIF and see if anything is triggered. So here's one. Sorry, it's loading. The connectivity in here is a little slow. And then you'll see it pop up on the device. So what you're going to see here is the messages will pop up on the device, but you won't actually get any triggers, which is interesting because I thought that I was supposed to be triggering something in core graphics and the CG PDF function. So okay, here we go. It's almost there. All right, you can see the phone. It got it. Got one. I sent two, but I'll just start talking about one. So there's two. So it's not going to have any hook, even though I'm actuating. Then if I click on messages and I actually open it, So I open the GIFs, then suddenly I'm like getting all these hooks, and it's like, oh, okay, so that's how the GIF is connected to PDF. But you're like, well, wait a minute, Christine, this is 0 click, and that was like for sure a click just now. So you're right. So we have to do something different. So what I did was I used my elite hacking skills to create a POC with Microsoft Word. So this was my exploit, and I saved this file as a PDF, and then I changed it from .pdf to .gif. So now if I send that to the phone, sorry, I gotta send it from my Google Drive. Now suddenly everything is triggering and there's no click. Sorry, it's very slow coming up on here. Okay. So that was, I didn't click, I didn't do anything, and it just suddenly triggered. What's really interesting is that there's nothing there, but you definitely saw it got an image message. So let me send that again because it's weird. So you can see I'm sending something, and my phone just buzzed. I guess you couldn't hear it, and then nothing comes in. But you can see these are hooking. So that's really interesting. I thought that was really interesting, and it's because it's a PDF. It's not a GIF, so it can't render. But these functions are being called. So something else you can do, Frida Trace actually. That's kind of like the instrumentation portion that I was talking about earlier, because remember, you're trying to hook functions, you're trying to harness this binary and insert debuggable code. So you actually get that when you use Frida Trace automatically. So in this folder, I'm in this Objective by the Sea folder, and I called Frida Trace. Frida will automatically, for me, create this handlers folder. And every single time all those functions lists, and you see like all those files that are like listed, that's everything that's being hooked. So I've run Frida Trace a bunch of times in this folder, so I have a lot of hooks that were already created. But you can see down here, core graphics is what I was hooking, and then all the core graphics source files. So it just creates kind of like a very generic, auto-generated, on entry, on leave, and then it just logs that it attached to this function. But here what's really interesting is now you have access to the arguments of that function, you have access to the return value of that function, and you can actually start to inject code. So this is where you can inject code into the process. So something else I want to show you is how to figure out the call chain of what's happening. So you can use this backtrace function from Frida so that you can print out the call chain happening during this trigger. So I know it's a little slow, but let's trigger this one more time with this backtrace. And I'm going to send my hack. And hopefully it sends a little faster. All right. Yeah, and now you can see the entire backtrace from this function. So this is laying the foundation for you if you wanted to reverse engineer this, because now you can see, okay, well, there's all these other functions that are called, and I definitely recommend like reading Mickey Jin's report, reading the Amnesty International report, looking at his call chain, and then reverse engineering the binary itself. So you can pull the binary off the phone and see which of these functions are connected to the exploited function. So Frida Trace is probably one of my favorite parts of Frida, but the thing I don't like is JavaScript. JavaScript is just not very friendly, which is why my third methodology is using Python. So it's really easy to use Python with Frida. all you have to do is install the Python bindings. So you can say pip3 install Frida, and now you have the Python bindings, and you can do everything that you do in Frida with Python. I really like it because I don't like writing JavaScript, so I feel like I can run my JavaScript files from Python, and then I can just iterate a little bit faster. You can also pass data back to Python and continue to operate on it. So something that's really frustrating for me is, especially in JavaScript, it has all these objects, and you're like, what is the type of this data? And they're just like, it's an object. And that's not useful at all. So Python gives you a little bit more verbose type information, so it's just better for me to pass it back. And special thanks to my coworker, Ryan Granginet, because he's really good at JavaScript. And I wanted to have a cooler demo, so he helped me with that. So special thanks, Ryan. All right, so now I'm going to show you some Python scripts that you can use. All right, so this script is pretty basic. It's like one of the boilerplate ones, and I just modified it to connect to one that I was using. So remember before we were doing Frida-U, you have to do a bunch of other things in Python to connect to it. So you have to get the device manager, actually connect to the device, enumerate the processes on the device, get USB device, but this, you can just read your script in with Python, and then you create and load your script. And so it's pretty easy. This is like all boilerplate. So what you can do is take your script that you wrote, and remember, this is the one that I was copying and pasting before, but now it's being loaded by Python. So to show you that it's the same, I can say Python 3, enumerate modules. Oh, and then you have to give it a process like you do with Frida. So we were doing Bluetooth D before, so I'm going to do Bluetooth D again. And you can see it printed out the same thing. So that's interesting, but we want to print out the data with Python, not with JavaScript. So what I'm going to do instead is comment out this console and use this function called send. And this will send my data over to Python. But then you have to receive the data also in Python. So that's where this on message comes in. So you can see there's this on message callback function, which allows you to pass data from JavaScript to Python. It passes it through a dictionary. So you can just pass message type equals send, and then you collect the payload from that dictionary, and you can print it. So now I'm going to print out the same thing, but from Python, instead of printing from JavaScript. Okay, so now you've seen me print the modules like 8 times, and you're probably bored. So let me show you something a little more interesting. I'm going to show you how to dump memory. So this is almost the same Python script, but this is connected to a different Frida script, this one. And so you can see again, I'm printing this data that's being sent, but everything else here is the same as it was before. This is what's changed, and this is why I don't like JavaScript, because this, what is this? So this is why you want to take all your bytes and pass it back, all of your data, and pass it back to Python. Because I don't know what to do with this. This was very hard. This is why I needed Brian's help, because I was like, what is happening here? Like, it kept trying to print it out as like this hex dump, and I was like, I just want the bytes. I don't want ASCII. What is going on here? So we love Python. We love doing things in Python. So once you parse all of this and do all this craziness in JavaScript, you can just send it back and get what you need. Then once you have a string of bytes, you can do so much more. So in Python, you already have access to all of these libraries. You have Capstone if you want to disassemble. You have all the representation things if you want to change it to bytes or something. So this is why I definitely recommend trying to move back from JavaScript into Python. So much better. That's a lot better than my original one was just printing out all these bytes, and it was not useful at all. So I definitely recommend trying to use Python to pass data back. Okay. So the last thing I want to show you are some hot tool tips that I've learned from some of my friends and peers in the industry who are part of the Frida community. So the first thing I saw on Twitter, so I recommend following Frida on Twitter. Hexploitable added this as a pull request because it's open source. You can do case-insensitive searching, which you're like, okay, like, is that really like that interesting? But it is, because you can actually access so many more functions. I really like using Frida Trace, and I like doing this actuation-based searching where I'm trying to actually run something and see the function that's triggered and figure out how to trigger it and why it's triggered and what the call chain is. But if I want to do that, I need to make sure that I get full coverage, because I might be triggering some function that like really doesn't matter and there's other really interesting function. Or if I'm not hooking enough functions, I might think that nothing is being triggered when really something is being triggered. So as an example, I'm going to show you Frida Trace with this case sensitive and how many more functions I can get just by using this case insensitive flag. Okay. Oh, also, do not copy and paste into the command line, because Frida will complain and you won't know why. All right, so let me show you first. Oh no, I did it again. Let me just retype. I'll just do -I star location. All right, so it's connecting. And I got 85 functions. That's kind of cool. That's okay. So if I do this /I, I get 94 functions. And you're like, all right, like that's pretty good. So what if we look at Objective-C? So this would be star for the plus minus, and then you need a star again for the class name, and then star location, and then gotta close. So this one I get 506 functions. That's pretty good, and that's why you want to look at both Objective-C and regular functions, because you might actually be using an Objective-C function and not a regular function. Now let's add that case-insensitive flag, which is interesting. And I get 660. That's like over 100 and more. So I really like using the case-insensitive searching, because especially like, let's say you just have a typo, like you will not hook the function that you think you're hooking, you'll miss it, and then you won't be able to do all those other things like putting a backtrace, examining the arguments. So you really want to make sure that you get as much coverage as possible when you're trying to find that needle in the haystack. All right. The next thing, I actually just learned this last week and I had to add it. Thank you, Dr. Jiska Klassen. She did a little presentation where she was showing everybody her methodologies on how she uses Frida, and she taught me this no pause flag, which is pretty awesome, because before I was complaining oh, when I'm trying to use Frida, I have to disconnect and then reconnect and disconnect, and that's why I like using Python. But this no pause flag is awesome because I actually don't have to do that. So Frida -u. Let me connect to Bluetooth D because that was faster. And then -L. No pause. All right. So now that I'm connected to this, I can change this to module name and module base. Let's say I want all the base addresses to print. So it just makes it a lot easier because instead of having to be in the command line, you can just modify this function. So I really like that. That was a really awesome thing that I learned. So I'm probably going to be using the CLI more now. Thank you, Jessica. And then the last thing that I learned was how to hook an ephemeral process, which was Olandre. They recently added this. This is still work in progress from Frida 15. So if you try it, there still might be some bugs. I tried it, and it was like hit or miss depending on the process. And this comes into play again with that zero-click exploit. If you read through the Amnesty International or the Citizen Lab or one of those reports, you'll see that there's this weird process called IM transfer agent that's one of the core functions in that call chain. And you actually can't connect to it. And it's because it's one of these ephemeral processes, so it's constantly respawning over and over again, and so you can't hook it. So they use this thing called spawn gating, and with the W flag, you can do it, and you have to pass the bundle ID and then -I open, and then that will create kind of like an open hook, and it waits for the process, and then it catches it once it runs. So it's a work in progress. I've tried it, and there are still like some issues, but I really think that it's a cool thing because I've run into ephemeral process before, and I'm like, I can't access this. Like, how am I supposed to hook this if it keeps dying? So I'm kind of looking forward to updates on that. All right, so in conclusion, Frida is free, so that's why you should use it. It is also open source, so if something is broken, make a ticket or make a contribution via GitHub. It's also easy to use, at least I hope you think that it's easy to use. So, if you have any questions, I think we have some time, or you can talk to me in Discord, or you can email me, Christine@herhackspodcast.com. Or you can message me on Twitter.
Some questions from the live stream.
Oh.
First one, can you trace C and Objective-C at the same time?
I don't think so.
And the other question is, do you have a GitHub repo?
Yes, I have to get it release reviewed, but yes, I can definitely do that. Yeah, oh my gosh, yeah.
So you talked about how you have to jailbreak before using this.
Yeah.
Can you run Frida on one of Apple's security devices if they get enrolled in that?
Oh, I don't know anything about their security device program. So yeah, I guess it depends. If the security device is debuggable with like Xcode, then maybe, because there is a way to use Frida. I didn't really want to demo it because I don't really use it for that. And so I was like, well, I could do this, but like I don't really use it this way. And that's more for like app debugging. So if you have a Mac and you have Xcode, there's like this thing called debug server, and you can use Frida. It's kind of like the same way that you can write test apps for your device and not have to jailbreak it. You can utilize that same thing and use Frida on like a non-jailbroken device. But for native processes, you have to jailbreak it. So the security device, if it's similar to production, then maybe.
That'd be nice.
That'd be cool. Yeah, hey, if you get a security device, I volunteer to take a look at it. Hook me up.